Hello, let's do concentration of ions in solution and dilution in stoichiometry. Calculate the concentration of ions in solution. So we were just dealing with how to make up solutions of known concentrations and how we can work out using the formula their concentrations. But we also need to consider that for ionic substances it's not always as straightforward as it is with covalent substances. The process of dissolving involves the ionic lattice breaking up. Remember when we talked about dissociation reactions and how the water molecules go into ionic lattices and pull apart and take away the cations and anions, i.e. they dissociate from each other. And so when we put an ionic solid like sodium carbonate into solution, what actually happens is this formula here. So we taking solid, put it in water, and we get sodium ions and carbonate ions in solution. And notice that we've balanced this, so there's a 2 in front of the sodium. Now think in terms of the molar ratio. If you have the molar ratio for this equation is 1 to 1, so if you have 1 mole of this, you must have 2 mole of sodium ions in solution and 1 mole of carbonate ions in solution, and any variation on that ratio. But that ratio governs what the concentration of the ions in solution. So we can calculate the concentration of the ions if we need to by working out using the mole ratio. And these concentrations are called ionic concentrations, which is a little bit different from all the other concentrations. Usually if we just asked you for what is the concentration of this solution of sodium carbonate, so in terms of what would be labelled on the container, we would label it as Na2CO3AQ, and we would be talking about the concentration of that. If you go on to year 12 physics, we need to know the concentration of the ions a little bit more, but just to make sure, just in physical science, you just need to recognize that as we learned earlier in the year, when it's an ionic substance is in aqueous solution, it dissociates into the ions, and the concentration of the ions will base itself on the molar ratio of the dissociation reaction. That's pretty much sums that up. And as I said earlier, if we have 1 litre of 1 mole, so if we know the concentration of this, or if we measured out 1 mole of this and put it into 1 litre, we would have a 1 molar sodium carbonate solution. Then we would have in solution 2 mole of sodium ions and 1 mole of carbonate ions. That's only if we have a litre. If we had less than a litre or more than a litre, that concentration would vary. Or that amount, sorry, this is the concentration, that's an amount. That's probably more precise. Now, dilution. With all solutions, we can concentrate them or dilute them, and we need to be able to do that. And a solution can be diluted quite simply by adding more solvent, most commonly water. And when we do add more water, the number of moles of the substance that we've dissolved remains the same, and therefore we need to calculate a new concentration. And we can do that as the volume increases with dilution, the concentration decreases. Now the converse of that is if we were to extract the water from the solution. An example of that is if we would boil off the water. As we boil it off, the remaining liquid or solution would get more concentrated. But we don't talk about that very often. Now we have this formula here, which is concentration times the volume of the before equals the concentration and the volume of the after. And it's a simple matter because both of these must equal the same amount of N. Like if we're to N1 must equal N2 because the number of moles of the solvent remains the same. Okay, let's do a quick example using the dilution formula to calculate the volume changes. what volume of 10 mole per litre stock hydrochloric acid is needed to prepare 25 millilitres of a 2 mole per litre hydrochloric acid solution. So this stock here just means it's the stuff that comes from the factory or we buy in great big bottles. That's all that means, doesn't mean anything else than that. So we're taking concentrated hydrochloric acid and we want to make a solution of weaker hydrochloric acid, and we only want 250 millilitres of it. And so how much of this do we take to make up the rest with water? So the volume 1 is unknown, but we've got the concentration to 10 mole. The volume required is known, converted to litres, as is the concentration. So we do the formula, using the formula, put the numbers in, rearrange it, and we discover that we only need 50 millilitres of the acid. Now a point to note here is, therefore, if we're making up this solution, okay, and we're told that we want 250 millilitres of 2 mole HCl, what this is made up of is we would have our 50 millilitres of concentrated acid, and we would measure out 200 millilitres of H2O. Sometimes we forget that we have to add the two together, because sometimes the question might be a little extension to that, and it might say how much water is needed to add to the acid, and so you have to work out how much acid you need and then subtract it from the required amount to get the amount of water. Alright, let's click this, and there's a couple of examples there. That's should be okay doing those ones, and in the next video, video number 5, we'll get into the serious stuff, mass concentration stoichiometry, which will be using all the skills you learnt in the last couple of videos and the ones before that actually. See ya.